So in this task, what we're supposed to use is pulse width modulation in order to actually work with the IoT. Now, what does pulse width modulation does is like like we actually deals with binary, so it's either one or zero. So when we want the voltage something in between, which means for the Arduino case it could be 1.5. Let's go with it. Even though it's 3.3 the highest voltage, let's take an example of 3 so that it's easier to understand. So 0 to 3. So the 0 would be considered as 0 voltage would be considered 0 and 3 voltage would be considered as 1. What if we want something in between, like 1.1? In that case, we have to use the pulse width modulation, and it's not that plain that we can have 1.1, 1.5 voltage. It's something like if you say this is the scale, and you say it's 3.3, and it's 0, or take it as 3. Now, when we are saying we want a 1.5 voltage, which is around this, so what does the graph look like? The graph doesn't start from in between. It is actually right here. So when it is around 1.5, it will be here. But what happens? It cuts. It becomes half. So it's half. Now what does that other half does is the other half comes at the below part. So it's high at the half of the time and low at the other half of the time. So it divides the time instead of dividing the actual voltage. That's what it does. Now let's look into the code. Now we have the H file. Our header file, it talks about the timer counter that I have chosen. It's 0. You can take 1 or 2 because all these keywords with the pulse width modulation. Now, and we have a timer. So timer does is pulsating, like it glows and then again it dims. So that's what the code will be doing over here. And we have the I explained this earlier as well, like I'm dealing with 1 megahertz frequency and how that is done because the help of the DA power 48, which runs on the general clock cycle 48 megahertz, and we have a general clock at 4, which divides it with 48, so giving us back the actual 1 megahertz frequency. That all those calculation is done inside the .cpu file. So it says like I'm using the general clock code, and then we have to start enable the peripheral because that would be then be starting it, reset it, like at the very beginning we have to reset it, and then the waves, configuring the wave for the single slope, and the timers, the frequencies, and everything. Let's look into the calculation. So here we get the 48 as I explained. Then I have setting up the which the prescaler would be 1 because it's already divided since the general clock pole which we are dealing with. Then the period would go, let's look into the period. So period is 1 over the frequency, so 1 over the 1000 gives out 1 milliseconds, which is ultimately 1000 microseconds. Now since one text takes about 1 microseconds, ultimately it would be 1000 for -1 in order to get the pulse. So that's why we have the 99. Now, in order to calculate the compared capture, that is the pulse uh, plus 1, which would give us 1000 and divided by 2, ultimately giving us the 500. So that's why when we are talking about the half duty cycle, it is denoted with the help of 500 in the code. And moreover, all those calculations here, and then we have basically P marks because we are playing around with multiple peripherals at the same period of time. So that's what that does, and then the same happens over here where we explain like what kind of urgent clock we are dealing with and the IDs and everything and P marks, and then moving on to the sketch file which shows like um, has a function called PWLED dimmer which shows like shows the LED have a glowing feature to it. Let's look into the circuit now. So I hope this is actually connected to the PA21, the anode, and the cathode is connected to the negative. So as you could observe, it dims and it glows. All this happens because of the PWM. Otherwise, because it plays around with the voltage, and it basically means it is bright half of the time and dim half of the time because the 50% of the duty cycle. So that's how you configure it. Thanks for watching the video.